Imagine having the power to bend the very fabric of space-time, to traverse across the galaxy at speeds that exceed the speed of light, to have the technology to build starships as they do in Star Trek that allow us to journey to the stars, with the ease of jumping into your car for an afternoon drive. The idea of a warp drive has fueled our imaginations for decades, a tantalizing possibility brought to life by science fiction. But is a warp drive really just fiction? Could we create and master the technology so that we can harness the awesome power of a warp drive, to create a bubble in space-time that allows us to cheat the ultimate speed limit of the universe? Are there any challenges that could make this dream insurmountable, making the dream of star travel impossible? Warp drives captivate our dreams of exploring the stars, but do the harsh realities of physics keep us from creating a warp drive forever out of reach? To understand if creating a warp drive is even possible, we need to break down what it would actually require to build one. The possibility and idea come from Einstein's theory of general relativity, which describes how massive objects bend the fabric of space and time. The larger the mass, the more an object bends the very fabric of space-time. In 1994, physicist Miguel Alcubierre proposed a theoretical framework for a warp drive, now known as the Alcubierre drive. The concept is simple yet awesome. A warp bubble would compress space in front of a spacecraft and expand it behind, effectively moving the ship faster than light without violating relativity. But here's the catch: it's not the ship that's moving through space, it's space itself. Sounds doable, right? Just fold space onto itself, create a bubble, and off we go. Well, not quite. Perhaps the biggest hurdle to overcome is the staggering amount of energy that's required to create this bubble in space. Alcubierre's equations suggest that to create a warp bubble, you'd need exotic matter with negative energy density. A lot of it. Think of negative energy as something that behaves completely opposite to normal matter. An anti-gravity-like force. The problem? We've never observed such matter in nature anywhere in the universe, except for brief moments in the quantum realm, and its existence remains purely theoretical. To make matters worse, even if it did exist, the energy demands for a warp drive are astronomical. Some estimates suggest it would take more energy than exists in the entire observable universe to power a single warp bubble, while others indicate it would take the mass of Jupiter converted into energy to power one. Regardless, unless we find a way to summon cosmic-level energy reserves, the idea of a functional warp drive is beyond even the dream stage of our ambitions. In Star Trek, their warp drive works by annihilating matter in the form of deuterium, a kind of hydrogen gas, and antimatter in a fusion reaction mediated by dilithium crystals. This produces the enormous power required to warp space-time and drive the ship faster than light. The only problem? It's fake. These are the made-up words of a screenwriter that have zero relevance in actually creating a warp drive. But let's assume, for argument's sake, that we find a way and solve the energy problem. That's not the end of our troubles. The very mechanics of a warp bubble introduce another terrifying challenge: stability. According to some models, even if you could create a warp bubble, the possibility of collapse the instant it forms is very real. It would obliterate the spacecraft, everything around it, and create a massive destructive reaction that our current understanding of physics doesn't allow us to determine its full magnitude. Worse yet, a warp bubble would most likely accumulate dangerous particles along its journey, releasing them as a catastrophic burst of radiation when it slows down. Imagine traveling faster than light, only to be incinerated as you reach your destination. Not exactly the heroic Starfleet mission we envisioned. Then there's the issue of causality, the idea that cause must always precede effect. A warp drive would effectively allow for faster-than-light travel, which could lead to violations of causality, creating paradoxes that defy logic. For example, you might send a message to your past self, altering events in a way that prevents the very message from being sent in the first place. These so-called closed time-like curves are a nightmare for physicists, suggesting that warp drives could break the very fabric of reality. On top of all this, we have the fundamental constraints of physics. Einstein's theory of relativity imposes a universal speed limit. Nothing can travel faster than light in normal space-time. While the warp drive concept cleverly sidesteps this by moving space itself, it's still bound by the rules of general relativity. Any deviation from these laws would require entirely new physics, something that rewrites our understanding of the universe. As of now, our best theories of space-time don't allow for warp drives to exist in any practical sense. Even if we ignore the physics for a moment, building a warp drive presents unimaginable engineering challenges. Constructing a device capable of manipulating space-time would require technologies far beyond anything we've ever conceived. We'd need materials that can withstand immense forces, mechanisms to generate and control negative energy, and a way to ensure the stability of the warp bubble, all without any real-world blueprint to guide us. This isn't like inventing the next airplane or rocket. It's like trying to build an entirely new universe inside a lab. But many people have suggested that looking back at the ingenuity of the human race and everything we have been able to achieve with technology, nothing stands between our dreams and reality. The important thing to consider is that virtually all of our technological innovations have come within our atmosphere. The only place in the universe where human beings thrive is within a 1-mile band around the Earth. Anywhere else and the human body will be destroyed by the environment around us very quickly. But the dream of a warp drive persists because it represents hope, a way to escape the limitations of our small, fragile world. The stars are impossibly far away from each other, with the nearest one to us being Proxima Centauri, over 4 light-years from Earth. At the speed of current spacecraft, it would take tens of thousands of years to get there. Warp drives offer the dream of a tantalizing shortcut, a way to reach distant worlds within a human lifetime. But for now, it's just that, a shortcut that exists only in our imaginations and on TV. So, is a warp drive truly impossible? The honest answer is that, with what we know now, it probably is. But the pursuit of the impossible has always driven humanity forward. Perhaps someday we'll find a way to bend the rules, to crack open the mysteries of space-time and journey into the mass expanse of our galaxy. Until then, the dream of a warp drive remains just that, a dream, tantalizing, distant, and achingly out of reach. Give us your thoughts on the possibility of humanity and warp drives in the comment section. Tell us what you think. I thank you for spending time with us as we uncover the possibilities of warp drives and interstellar travel, and invite you back for our next episode